Hello and welcome to Pertrain's Certified Cost Preparation course. In this lecture we will talk about project management fundamentals. Let us get it started. In today's difficult and challenging business environment, in order to sustain, it is vital that the management of projects results in identifying risks, maximizing cost savings, minimizing time delays, and improving economic return. These results can only be achieved through effective management of people, tough but fair project objectives, efficient business techniques, and outstanding leadership skills. This project management lecture covers these subjects in considerable detail. The roles, functions, and interfaces of company management, project management, engineering management, construction management, and support service groups are explored. Overall relationships and personnel relationships, essential for successful project execution, are outlined. Throughout the lecture, the emphasis is on practical approaches and the relationships of personnel in the project team. The emphasis is on the need for and substance of early project planning and the related scheduling of time and development of costs. It is essential that all project leaders be effective professional project managers. They need to be organizers, planners, motivators, communicators, and businesspersons. If we get it right at the front end, we have a chance of success, though not guaranteed. If we don't get it right, then we have no chance of success. The learning objective of this lecture is to understand the roles and responsibilities of project management. Project execution, old versus new, the changing role of managing projects. In order to understand the role of project management, how project management has improved the performance of the construction industry over time. Let's quickly review the history of project management. First, let's understand the conventional way of project management, which was a period of 1950s to 1970s. During the period, projects were carried out in a typical sequence of complete design, complete procurement, installation and construction, inspect and fix, and at last, commissioning and a startup. Typically, one step was completed prior to commencement of the next step. The old program of sequential completion of the individual phases of engineering, procurement, and construction, where construction management rarely got involved until 4 weeks prior to opening the site. However, followed by explosion of work that took place in World War II, the construction project management witnessed major shift in management principles and philosophies. The focus shifted to early completion of the project, followed by efficient business management of the project. New construction management now focuses on pre-planning, constructability, contract administration, and business management. Over the past 40 years there have been major improvements in project execution, but surprisingly, the most significant PM tool and philosophies can be narrowed to less than 10. These developments are the following: Critical Path Method, CPM, scheduling, Fast Track Scheduling Program, Independent Construction Management, Partnering, Contracting Arrangement, Total Quality Management, TQM, Participative and Open Book Management, Design Quality Assurance, Value Engineering, and at last, Project Management Performance Measurement. Fast Tracking and Critical Path Method, CPM, scheduling are the greatest advances in methodology. Today's computer systems greatly assist in the collection and collation of data for these three programs. This data, in turn, is developed into specific cost and schedule project baselines and essential information. The development of the Fast Track, which was first published in 1982, was of particular importance. This technique is used in conjunction with construction complexity and labor density. With the advent of today's project management tools and philosophy, and the business requirements, the role of construction project management is shifted from Its old reactive way to modern proactive way. The best of today's construction management now take a proactive role through the newly developed programs of construction pre-planning and constructability. This results in a strong construction involvement at the early stage of the project to ensure that engineering design and early planning fully recognize the requirements of an economic construction program. An example of construction pre-planning is backward scheduling, where the overall project schedule is structured around the construction schedule, with design drawing issues and material deliveries being matched to construction needs. If this is done early in the design stage, there is no cost impact on design engineering or purchasing, and the construction cost savings can be considerable. Business management is now considered of greater value than the old standard of aggressively pushing the work, with cost and contractual considerations of lesser consequence. When we are discussing project management in this lecture, it is must to have a definition of project. There are several definitions of projects. One definition is: a project can be defined loosely as an item of work that requires planning, organizing, dedication of resources, and expenditure of funds in order to produce a concept, a product, or a plant. Project Management Body of Knowledge, PMBOK, issued by Project Management Institute, PMI, defines a project as a temporary endeavor undertaken to create a unique product, service or result. Let's understand this definition in greater detail. Temporary and unique are two key features of any project. Temporary defines that a project has a certain beginning and a certain end. Unique defines that project outputs are unique, or in other words, this product or service is being developed for the first time. As the output the project is unique, so are the projects. Who are project managers? Project managers are personnel who are trained, skilled, and dedicated to lead the execution of the company's projects. The project manager is supported by functional professionals such as design engineers, procurement personnel, contracts administrators, cost engineers, schedulers, construction managers, and other assisting personnel like accounts, document control, etc. In many cases, the type, size, and complexity of projects vary greatly, and therefore, the skills and experience of project engineers, project managers, and support personnel can, similarly, vary in capability. The main function of project management in any project is cost management, time management, human resources, and communications. We will discuss these functions in detail in upcoming slides. To complete the project within budget is one of the project objectives, therefore one of the project management functions. Many projects have project cost as the top objective, and this requires the project to be completed at, or less than, the budgeted cost. Significant business skills are essential to meet this objective. Cost estimation and cost control are two essential skills required for this. To deliver the project for use of end user at a predetermined date is generally one of the project objectives. Projects may have schedule as the top objective. Additionally, to meet the project cost objective, it is necessary to manage time efficiently. The project indirect expenses increase with time, therefore increase in the project duration can lead to project cost increase. This means the predetermined schedule, upon which the cost was based, must be met and met economically. In such cases, acceleration programs are planned, and it is probable that there will be corresponding cost increases to the economic-based project. Projects are designed and built by people, not companies. People do it singly, or in multiple groups, and if there are skilled people and good relationships, there is a chance of success. If the people and relationships are poor, there is little chances of success. Therefore, human resources management is the most important and critical for the project's success. Of all the resources required for projects, the people resources are the most difficult to manage. Interpersonal skills and the effective motivation of people, at all levels, are essential for successful project execution. Lack of human resources, plus a corresponding lack of the correct mix of people skills, are becoming an increasing feature of the project business. Therefore, the project success is based on adequate personnel for the project, skill of the project personnel, and team motivation. A project manager spends maximum amount of his work time communicating with others. A formal and informal structure of effective communications is essential for successful project execution. In addition to weak people skills, many company organizations and cultures have poor administrative practices that also form barriers to project success. The conflicts or barriers are caused by departmental jealousies, rivalries, and failures by management to communication culture. Projects often fail because we simply fail to clearly articulate the vision and the project's success criteria. This vision must be successfully communicated to each stakeholder and team member. The whole team should be able to visualize the end result, in order to work towards a common goal. Communication in projects are not limited to verbal communication and leading the people by communication. It also includes formal communication such as reporting and contractual correspondences with stakeholders. Regular reporting of the project's progress and status is crucial to the success of the project. Communicating this to all stakeholders in a clear and precise manner is paramount, so that all understand what the key messages are. Diagrams, charts, graphs and tables should be maximized here. The well-known saying "a picture is worth 1,000 words" is no less true than when communicating project progress or status. So far, we talked about what is project management, what is project, and what are key elements of project management. Now let us talk about project life cycle. Here we shall discuss general steps starting from inception to completion in a common project setting. Project initiates as part of company planning. The requirement of project may necessitate due to requirements of affiliates, or company-owned operation, or maintenance needs. Company plans may be annual, or 5 years. Company planning is generally driven by company overall business strategy. Upon finalization of plans, an engineering request is sent to engineering department. The engineering department can be plant or central, based on structure of the organization. The next step is project development. Project development is about developing a technical, regulatory and economic case of the project. Next step is to obtain budgetary approval from the company management. These steps are described in more details in later slides. And the final step is to execute the project. Small projects are delivered through cost-plus engineering or lump-sum procurement model, whereas large projects are delivered through EPC or lump-sum or cost-plus. Experience in this process, recognition of each company program's individualities, and the skills of bridging the matrix interface conflicts, are necessary for project success. Getting the front-end planning right is the key to successful project delivery. As discussed, one of the steps in project lifecycle is engineer request. Reason for making any engineering requests can be to solve problem, upgrade quality, addition quantity, address environmental issues, stay in business. Engineering requests are sent to engineering department for project development. Timely and quality assessments of plant requirements are difficult to achieve, but are essential for company profitability. Such assessments result in formal engineering requests for the project work. Next we shall learn the steps of project development. Flowchart on the screen shows major components for developing the scope of each project. Each of these components, technical, project conditions, regulatory, cost, and economic, is then further defined and prioritized. It is vital that the project priorities are clearly established. While the flowchart is self-explanatory, you may choose to pause the video and spend a couple of minutes relating your past project experience with major components identified in developing project scope in this flowchart. The time and interface relationship of major project phases is shown in this flowchart. Assuming a fast-track program, most of these phases will overlap, and the degree of overlapping will depend on the work content of each phase and the efficiency of decision-making present in the project. In a typical project, phases are: 1. Development planning. This is driven by company and market strategy. 2. Feasibility study. Various scenario analysis are carried out using design option and cases. 3. Conceptual study. Case selection and optimization are done at this stage. 4. Project planning. Plan how to execute the project and plan contracting. 5. Basic design. Work scope is defined at this phase. 6. Detailed design and procurement. 7. Construction. 8. Commission and startup. Projects are designed and built by people, not companies. People do it singly, or in multiple groups, and if there are skilled people and good relationships, there is a chance of success. If the people and relationships are poor, there is little chance of success. That makes teamwork ever more critical for success for capital projects. This matter has become the vital issue to profitability, especially as companies downsize and reduce the core. Greater personnel efficiency and increased operational quality are essential requirements in today's difficult business environment. In the absence of an aggressive, creative, analytical cost engineering and project controls function, role of cost engineer limits to retroactive, record keeping. This is called bean counter syndrome. Beans are a cheap commodity, so to count them is a rather silly thing to do. A bean counter is one who nitpicks over small things in order to save costs. This practice has two major contributing factors. First, project manager reluctance toward an effective cost management function. Second, the cost engineer can be directly responsible for this practice, as the individual does not possess the essential analytical skills, or does not believe in an aggressive trending approach and or does not possess the essential people/communication skills. They are, in fact, content with a bean counting role. There is a much wider acceptance today of the need for dynamic, proactive cost engineering trending. It is to be hoped that cost engineering and project controls functions will become a pivotal project role. This is due to the fact that effective cost trending and controls are essential for project success.
So, we are at the end of project management lecture. Let's quickly recap what we have learned in this lecture. In this lecture we have learned: what is project? We understood that a project is a temporary endeavor undertaken to create a unique product, service or result. What is project management and its functions? Here we talked about who are project managers, and understood that the project managers are trained, skilled, and dedicated person who lead the project execution. The main function of project management is cost management, time management, human resources management and communication. We also talked about how construction project management philosophies are evolved over the years. And what are current construction project management trends? Here we discuss that the role of project management changed from historically being reactive to now being proactive. What are elements of project life cycle? Here we noted that project life cycle in typical organization passes through company planning, engineering request, budgeting, and management approval and project execution. What are major project phases? Major project phases in a typical project are development planning, feasibility study, conceptual study, project planning, basic design, detailed design, and procurement, construction, commission, and startup. In the end of the lecture we talked about what is bean counter syndrome. We understood that bean counter syndrome is a reactive approach by cost engineer and project controls professional towards project performance measurement. With this we complete this lecture. In next lecture we'll talk about project organizational structure.